Hello students, welcome back in another session in which we are going to study about classification of organic compounds which is based on functional groups. Uh, Organic compound having its important property that each and every organic compound have its own functional group. An atom or a group of atom in the organic molecule which determines its characteristics chemical property is called as functional group. And the chemistry of every organic molecule, regardless of size and complexity, it is determined by its functional group. And therefore, functional group is a very important property of organic compounds. So, here example, propanol, CH3, CH2, CH2OH. So in that part of an organic molecule which undergoes the change as a result of a reaction is the functional group. And here in this structure, OH is the functional group present in the propanol. And inspection of the structure of various organic compound tells us that there are a large variety of functional group present in them, and the resulting individual class is called as family, named after the constituents functional group. Like the example, family of alcohol, family of halogen derivative. See here, in this structure, OH is the functional group from the alcohol family. Before you have to start for this in detail for the functional group, first you know about the alkyl radical. So here that R, and this is one dash, that means unused valency, where that R is equal to CH3 C2H5, means from CH4 if we replace one hydrogen or to get here CH3, it is called as methyl radical. From CH3 CH2, one replacement of one H, formation of ethyl radical. Ethyl radical means, see here, by the removal of hydrogen, what we get here, the structure is called as the alkyl radical. And if these alkyl radicals are with this different functional group, like here, this is for the alkyl halides, Rx, where R is equal to CH3, C2H5, and halogens, fluorine, chlorine, bromine, iodine. So, iodoethane, iodine is a functional group. Here 2-chloropropane, chlorine is a functional group. 1-bromo, 2-methyl propane, where the Br is a functional group. These are the structures for alkyl halides having the general formula Rx, and X is the functional group. For the aryl halides, see here, its general formula is ARX. What is AR? These are the aromatic structures, ring, benzene. And when these are with these halides, these are called as the aryl halides. Fluorobenzene, chlorobenzene, bromobenzene, iodobenzene. These are the examples for aryl halides. Cyanides, or it is also called as nitriles. General formula is RC triple bond N, where Cn is the functional group. Okay. Example, methyl cyanide CH3 C triple bond N. It is also called as acetonitrile. And see here, ARCN means this is an example for the aromatic cyanide, cyanobenzene. Its name for this structure. See, this is for the cyclohexane carbonitrile, where this is a benzene ring, cyclohexane ring means a saturated ring with the CN. So these are the examples for the cyanides which contain the functional group C triple bond N. This is for the isocyanide. Cyanide having CN functional group. For the isocyanide, N triple bond C. Isocyanide is an organic compound with the functional group N triple bond C, and it is the isomer of the related nitrile. Hence, that isocyanide name it is used. See here, the functional group is NC. Methyl isocyanide example, and for the aromatic isocyanide C6H5NC, phenyl isocyanide, where nitrogen is positively charged and carbon get the negative charge. So this is for the isocyanide. NO2 is for the nitro compound. Okay, the functional group is NO2, general formula RNO2, and see the examples for the aliphatic nitro compound nitromethane. Nitromethane. This is the nitromethane, nitroethane, nitropropane. These are the example for the RNO2 group. And they also show the primary, secondary, and tertiary structures. These are the example for the aromatic compounds with the benzene ring, and on the benzene ring presence of NO2 group, 1,2-dinitrobenzene, 1-nitronaphthalene. Okay, so 2,4,6 trinitrotoluene. Toluene means C6H5CH3, and at the second, fourth, and sixth carbon atom NO2 group. So this is for the nitro group, functional group NO2. For alcohols, functional group is OH, general formula ROH. Ethanol, propanol, and 2-methyl propanol. They also shows the primary, secondary, and tertiary structures. And see, for the aromatic alcohols, OH group is with this C6H5CH2. Means if that OH group is present on the side chain of benzene ring, these are considered as a alcohol. See the another structure where methyl group is also present. So these are the example for the alcohols, aliphatic alcohols as well as aromatic alcohols. This is for the phenols. See here the first structure for the phenol where the OH group is directly present on the carbon, and the carbon which is present in the ring. For the alcohol, what is the OH is present on the side chain of the benzene. Okay, but here OH group is present directly on the benzene ring. Metabromophenol, orthocresol, where at ortho position CH3 group is present. So all these examples, salicylic acid, resorcinol, catechol, hydroquinone, these are the example for the phenol. They also contain the another functional group. See here the last example, para hydroxybenzoic acid. Here carboxylic acid is also present, and OH, that phenol is also present. Means all these are the example for the phenol. For amines, general formula is RNH2. See here the first structure is for the ammonia NH3, and where the nitrogen is bonded with the 3 hydrogen. When one hydrogen is replaced by alkyl group, formation of a amines means RNH2. When two hydrogens are replaced by the two alkyl group, formation of secondary amine. And in case of tertiary amines, nitrogen is not bonded with the hydrogen. It is completed with the valency with the 3 carbon. And therefore these are the example for the primary, secondary, and tertiary amines. And see here for the ammonium ion, which is the NH4 plus. When the nitrogen is bonded with the 4 hydrogen, nitrogen get positive charge. Therefore, it is called as ammonium ion. And from ammonium ion, if one hydrogen is replaced, it is called as primary ammonium ion. Like that, it forms secondary, tertiary, and if all the hydrogens are replaced by the alkyl group, it is referred as quaternary ammonium ion. So NH2 is functional group here for the primary amines. Only for the primary amines, what we can say, the functional group is RNH2. For secondary, it shows RNHR, and for tertiary, it shows N. Okay, so this is for the amines. Some more examples: methylamine. This is for the dimethylamine, where 2 hydrogens are replaced. There, all these 3 hydrogens are replaced. So trimethylamine. Here, all these CH3 groups are same. What is here? But it is also possible. One is C2H5, one is CH3. This is also C2H5. So you can take here any different alkyl group, you get the different amine structure. For the aldehydes, RCHO is the general formula. Aldehydes contain CHO as a functional group, where the carbon valency, 2 valency completed with the oxygens, therefore it shows the C double bond O and H. Aldehyde, the first member from the aldehyde family is acetaldehyde, having the formula CH3CHO. Before that, formaldehyde is present, HCHO. The acetaldehyde is the second member which contain the 2 carbons. See, first is the formaldehyde which contain 1 carbon atom, and it is, as it is a 1 carbon atom, its IUPAC name is methanol. They are ending with the al, aldehydes, and therefore methanol, ethanol, propanol. These are the example for the aldehyde family. And for the aromatic aldehyde, benzaldehyde is the first member of aldehyde family, C6H5CHO. So this is for the aldehyde which contain C double bond OH functional group. For ketones, R C double bond O R. Here the C double bond O is bonded to the both side by the carbon, or what we can say alkyl group, and therefore the first member of the ketone family, it contains three carbon atom, two carbon for the from the alkyl group and one is for the carbonyl group. Both the aldehyde and ketone contain carbonyl group, but for the aldehyde CHO and for the ketone RC double bond O R dash. So acetone or 2-propanone is a example for the ketone family. If we increase the chain by introducing the more alkyl group, we get the higher ketone. Here 2-butanone. We have to indicate here the position by counting this number carbon atom, by numbering. This is the carbon number 1 and this is the carbon number 2, and therefore 2-butanone is the example for the ketone. Acetophenone, it is example for the aromatic ketone, where one R is CH3 and one R is the benzene ring. If the both are, these are the aromatic ring. So this is example for the diphenyl ketone. Okay, or what we can see here, benzophenone. Benzophenone means where both the R are aromatic ring. So for these ketones, they contain the functional group RC double bond O R dash. Carbonyl group is called as ketonic carbonyl group. For ethers, ROR dash. Ethers are, what we can see here, these are the derivative of H2O, dialkyl derivative of water, where these, if you consider the formula for the water H2O, so if these two H are replaced by the alkyl group, what you get here, ROR dash. And that if R are same, both the R are same, these are called as symmetrical ether. Here C2H5 O C2H5, diethyl ether or dimethyl ether. Or see here one more example, diethyl ether. In the diethyl ether, see if you are to given here its IUPAC name, then these are referred as alkoxyalkanes. Here for the dimethyl ether, methoxymethane means one group is considered as a alkoxy group and one group is referred as a alkane, parent alkane. Therefore methoxymethane. Here ethoxyethane. Similarly here that ethane is considered as a parent alkane and the smaller group is referred as a alkoxy group, and therefore methoxyethane is its IUPAC name. So this is for the ethers which having the general formula ROR. For carboxylic acid, RC double bond OOH, which contain the functional group C double bond OOH. They also contain the carbonyl group, but with OH group is also is present in the carboxylic acids. Methanic acid is the first member HC double bond OOH. Ethanic acid or acetic acid CH3C double bond OH. So by introducing the more number of carbon atom, we can increase the chain according to the that you get the respective acid. It may be the straight or branch chain, but you get here the higher carboxylic acid by adding the more number of carbon atom. See this for the penteonic acid, which contain 5 carbon atom and with the carboxylic group. Always the carboxylic group is present at the terminal position. So you have to start a numbering from this by counting this number as a carbon number 1 carboxylic carbon atom in a chain. So this is for the carboxylic acid. For esters, RC double bond O OR dash. Here it contains carbonyl group and alkoxy group, and combinedly it form ester as a functional group RC double bond O OR dash. See here for the example, ethyl methionate. So these are the two carbon atom, therefore these are referred as ethyl, and methionate as by this carbon number 1. So 1 C double bond O and therefore it is referred as a methionate. Similarly here methyl pentionate. See this one is the smaller group methyl group. It is named according to that one is the alkyl group and one is the alkynoid group. The carbon atom which is joined with the C double bond OO, it is referred as a alkynate. Here C double bond O, that carbon is joined with this chain and therefore these are 5 carbon atom, it is referred as a pentanate and methyl group and therefore methyl pentanate. This is for the ethyl benzoate. See here, that it is C double bond O. O is bonded with the benzene ring, and therefore benzoate, and ethyl group is with this benzoate ring, and therefore ethyl benzoate. Means now see for here what we did here, that you just break these compounds in the two parts. C double bond O, carbon is bonded here with this hydrogen, and therefore it is referred as a methionate. And you break this compound here in the two part. One is the ethyl, its name is ethyl methionate. For the amides, they contain the functional group RC double bond O NH2. So here for the primary amides, see here, this is the NH2 group R and C double bond O NH2. For the secondary amine RC double bond O NH, one more hydrogen from this, it is replaced by alkyl group. For tertiary amines, that nitrogen is bonded to the 3 side by the carbon atom. Means there is no bonding between the nitrogen and hydrogen in the tertiary amine. For the secondary, nitrogen is bonded with the 1 hydrogen, and for primary, nitrogen is bonded with the 2 hydrogen. So C double bond O NH2 is the functional group for the amides. You can take any alkyl group for this, like R is equal to CH3CH2, and count this carbon also, C double bond O NH2. 3 carbon atom, and with the C double bond O NH2, it is referred as propanamide. Propanamide or N-methyl propanamide and N-dimethyl propanamide. These are the examples for the amides. Now see here, N, it refers that it is a secondary amine, okay, NH. And here see that nitrogen is not bonded with the hydrogen. It bonded to the all side, to the 3 side by the carbon. It is example for the tertiary amine, and tertiary amines, they are indicated by the N-N, and the structure for this dimethyl propanamide. So N, capital N, it is indication used to indicate the primary, secondary and tertiary amines. For the primary, no need to write N. For secondary, one time N, and for tertiary, N comma N. So RC double bond O NH2, it is for the amides. For the acid anhydride, R C double bond O, O C double bond O R. Here for the anhydride structure, what they having C double bond O, C double bond O, and these 2 carbons are linked here with the alkyl group. And the presence of this structure, this is a middle one structure, it's called as the anhydride group or anhydride structure. If R is equal to H, so what you get structure is for the methionic anhydride, means C double anhydride indicate that it contains C double bond O, O C double bond O, and therefore it is a methanic anhydride as 1 carbon atom. If CH3C double bond O, acetic anhydride. If both the R is equal to benzene ring, benzoic anhydride. So here is the 2R or 2AR, they are joined by C double bond O, O C double bond. Or we can write here C double bond O twice O. Okay, alkyl group R, C double bond O, out of the bracket twice O. So this is for the anhydride. For acyl chlorides, R C double bond O Cl. So here very simple example for this acyl chlorides, ethional chloride. If R is equal to aliphatic chain CH3, C2H5. So you have to count this carbon atom also, as it contains 2 carbon with the C double bond O Cl. Its name is ethional chloride. Here 3 carbon atom, therefore propionyl chloride. And for aromatic acyl chloride, benzoyl chloride, C6H5 C double bond OCl is example for benzoyl chloride, which is a acyl chloride, contain the functional group C double bond OCl. For sulfonic acid, here R SO3H, okay, where SO3H is the functional group. This is a general formula for the sulfonic acid. And if R is equal to CH3, we get the methyl sulfonic acid, ethyl sulfonic acid for the C2H5OH, for the C2H5. So like that here, if you change your alkyl group, according to that you get here the alkyl sulfonic acid. For aromatic sulfonic acid, R is equal to C6H5. Therefore, its name is benzene sulfonic acid, C6H5SO3H. And this is for the hydrocarbons, saturated and unsaturated, alkane, alkene, alkynes, and aromatic compounds like arenes. From the alkanes are saturated. For the alkenes, which contain carbon-carbon double bond, alkyne carbon-carbon triple bond. So these are the functional groups which are present in the alkene and alkyne, carbon-carbon double bond and carbon-carbon triple bond. For the aromatic arenes, C double bond O unsaturation character. For the hydrocarbons, this is the for the alkane family, methane, ethane, propane. This is for the alkene family, ethene, propene, butane, which contain at least one carbon-carbon double bond for the alkene. For the alkanes, these are the saturated, no double bond is present here. All these carbons are linked to each other by a single bond. This is for the alkyne, say ethyne, propyne, butane, which contain carbon-carbon triple bond as a functional group. So this is for the hydrocarbons, alkane, alkene, and alkyne. These are some more examples for the functional group with their structure. See, for the carboxylic acid, they contain RC double bond OH. For the esters, RC double bond O R dash. For amides, RC double bond O NHR. So these are the just name and with their structure of the functional group. And some more example for the aromatic compounds. See, this is example for the toluene. So toluene contain CH3 group with the benzene ring. For the so this is a alkyl halide structure. For the phenol, which contain OH group, hydroxy and aromatic hydroxy and phenolic OH group. So this is the phenolic OH group, hydroxy group. For aniline, it contain NH2 as a functional group. For benzoic acid, C6H5 C double, so C double bond OH is the functional group. For the benzaldehyde, it contains CHO as a functional group. For anisole, if this is a O and here that one more alkyl group is present here. This is a bond line formula and therefore it's a example for ether. Next example is for the sulfonic acid SO3H. C double bond OCH3 and here one more side with the benzene ring. So this is example for the ketone which contain the functional group ketone. Why? Because the C double bond is bonded to the both side with the carbon. This is example styrene which contain the functional group alkene. Okay, as it shows the double bond here. So these are the different examples of the aromatic compound which contain the different functional group. So this is for the all about the organic compound which contain the different functional group. Thank you.